Good morning, this is Mr. Morales, and by popular request in ninth period, I'm going to redo my notes, or actually, I'm going to record my notes on system of equations that we did this past Monday for Algebra 2. So on the top, I didn't write it down, but as we know by now, a system of equations is when we're looking for the solution to two or more linear equations specifically. So let me go ahead and just get my pen going here. First thing in the morning, I apologize. Okay, so a system of equations is when we're basically dealing with two or more linear equations. I apologize for my handwriting. Now, when we're dealing with systems of equations, there's three types of solutions we can arrive to. Now, the first one here, it says, is one solution. That's when you have two lines that intersect somewhere, and that point of intersection, that x and y value, is the solution. So that's your first case scenario. Next, we would have no solution. That happens when you have two lines that never intersect, or in other words, that are parallel. So when you have this happening, you have no solution because there's never a point of intersection. I forgot my arrow tips here on the first one. I'll draw those really quick. And then we have the idea of the infinite solution. This happens when you graph your first line, and let's say it's something like this. And actually, let me just change my example, because all my slopes seem to be negative there. Let's go ahead and say we have a line that goes through something like this. All right, so there's our line. And then we get our second line, and we graph it, and we happen to get the same exact line. Well, in that case, the second and first line are infinitely in contact with each other, so therefore we have infinite number of solutions. So these are the three types of scenarios you're going to get. Mathematically, these will show themselves in different ways. So let's go ahead and just begin our examples down here. So below it says solve by graphing. Solve each system of equations by below by graphing. Identify the solution. So knowing what we know about graphing linear equations, we should make quick work, hopefully, of this. So, number one, our first equation says y equals negative 5/3 x minus 6. This last number at the end, let me go ahead and hold the screen there. This negative 6 is my y-intercept. So I'll go ahead and make a point there. And then the negative 5/3 is my slope. So that means go down 5, right 3. However, I don't have enough spaces to go down 5 and right 3. I'll run off the grid. But I can find the point that came before this by following the slope backwards. I can go left 3 and up 5. So I can go 1, 2, 3 and up 1, 2, 3, 4, 5 and put a nice big dot right there. And then I can fill in as many points using the slope in backwards order. So I can go back 3, 1, 2, 3, and up 5, 1, 2, 3, 4, 5. So you can go ahead and get there right there. And then maybe one more point. Back 3, 1, 2, 3, and up 5, 1, 2, 3, 4, 5. Now, I'm doing this on the screen, so getting a straight line is a little difficult, so I'm going to ask for your forgiveness. But however, I'll give this first line a go. So I'll go ahead and line up my dots. And with your ID or with your ruler, you'll go ahead and just make a line that goes through those points. And that one was kind of pathetic, but maybe as I practice more, I'll get better. So now let's graph our second equation here, which is also in slope-intercept form, which means the last number at the end is my y-intercept, which is up here at positive 5, and its slope is 1 over 6. That means I go up 1 square, and over 6. 1, 2, 3, 4, 5, 6. Now I can't go up 1 over 6 because I'll run off the grid, so I'll try to get the point that came before this. I'll do that by going back 6. 1, 2, 3, 4, 5, 6, and down 1. And what do you know? We have contact here. So if I connect all the points of this second dot, and once again I will try to make a straight line, but no promises. Let's see if I can get this going. Hey, that was a little better. Nicely done. We get our intersection, and our intersection is at negative 6, comma 4. That means if you plug in a negative 6 for x in both these equations, you'll get an answer of positive 4, because they both equal the same exact thing at that point. That's what the solution means. Let's go ahead and move on now to number 2. Number 2 gives us an equation that just simply says y equals 5. That means you go to the y-axis, you go to positive 5, which is right here, and I'll throw a dot there. You want to make a line that goes through every point where y has a positive 5 value. Well, that'll end up giving you basically an infinite line that goes right through. A little better. So that's what a y line looks like. A y line will be a horizontal left-right line. And its location depends on the number, in this case, positive 5. Now let's go ahead and graph our second equation, which luckily for us is in slope-intercept form. So the plus 7 at the end is my y-intercept. And then my slope is positive 2, which could be written as 2 over 1, up 2 over 1. I run out of space, so I'll follow this in reverse. Back 1, down 2. And right there, I have a solution. I'll go ahead and fill in the rest of my points just to get my graph accurate. Because after all, this is math class. And accuracy and precision are important. So let's go ahead and get the graph going because I'm supposed to be solving by graphing. There we go. Hey, I'm getting better at this. And the point of intersection for these two lines is at -1, 5. So here's the 2 basic examples of a single solution system of equations solved by graphing. Now we go on to number 3. Number 3, we have this in a different type of form. We have these equations in standard form. Well, if you had Mr. Morales, me, for Algebra 1, we learned a few tricks last year. And I still wouldn't be surprised if, even if you had me for class, you don't remember these tricks. So here's how it breaks down. Standard form means you have a number with x and a number with y, that we'll call a and b separately. And those 2 numbers are on the same side of the equation. On the other side is a single number, positive or negative, it doesn't matter. We'll call that number c. There's a quick way to get your 2 points to make your line, because that's all you really need to make a line, or 2 really good points. So the first thing I'll do is I'll look for my y-intercept. My y-intercept can be described as, or a shortcut, a hack in other words, would be to take your c number and divide it by your b number. In this case, -45 divided by -5. And when I do that, I get a y-intercept of -45 divided by -5 gives me a positive 9. So I'll go ahead and go to positive 9 on the y-axis. And here's my y-intercept of my first equation. Now I need either another point or a slope. And I can get the slope pretty easily. There's another little hack. To get your slope, which we call m, all you have to do is take the opposite value of whatever your a number is and divide it by your b value. So if a was negative, make it positive. If a was positive, make it negative. In this case, my a value is a positive 6 up here. So I'm going to make it a -6 divided by my b value, which is this minus or -5. Now, before I can do anything, I have to remember one last rule. A negative divided by a negative is a positive. So I have a slope of positive 6 over 5. That means I go up 6 over 5. Well, like in the last example, I don't have enough space to go up to the next point, so I'll have to go to the previous points by following the slope in reverse. So instead of going up 6, right 5, I'll go left 5, down 6. So 1, 2, 3, 4, 5, down 6. 1, 2, 3, 4, 5, 6. And I'll go ahead and put a point right there. And then I can do at least one more point. I can go, it's going to be what? Down 6. 1, 2, 3, 4, 5, 6 over 5. 1, 2, 3, 4, 5. And get one last point in there. So I got these 3 points. And let's see if I can get a decent straight line again. So let's go ahead and line them all up. Get my ruler. And not too bad. Got them all lined up there. Now let's graph our second line, and I'll do the same thing using the hacks I just learned. To get the y-intercept, what I need to do is take my c value and divide it by my b value. In the second equation, I have a positive 2 for a, another positive 2 for b, and a -4 for c. So I'll take that -4, divided by my b value, which is positive 2, and I get an answer of -2. So there is my y-intercept, down here at -2. To get my slope, I take whatever my A value is and make it the opposite and divide it by my B value. In this case, my A is a positive 2, which then turns into a negative 2. I divide it by my B value, which is also, in this case, a 2. Negative 2 divided by positive 2 reduces or simplifies to a negative 1. That means I'm going to be going down 1 over 1. Down 1 over 1 in reverse to get all my points. Which is great, but if I want to find a solution, I shouldn't be going away from my other line. I want to go towards my line. So I'll just follow my slope in reverse and get to a point of intersection, which is right there. And I'll fill in the rest. Whoops, and then create my line. Let's go ahead and get that done. So from here, that did not even come out. I don't know why. I'll try this again. This is going to look really bad, I'm not even going to lie. Oh, actually, better than I thought. So our solution is where they intersect right here, and our solution then is at negative 5, positive 3. Now let's move on to number 4. Number 4 gives us two equations. One's in standard form, which is the first one, and the second one's in slope-intercept. Since slope-intercept I find is way easier and faster, I'll start with that one. So I'll graph this line in this reddish color. My y-intercept's at negative 5, which is down here. My slope is negative 1/2, which means down 1 over 2. Down 1 over 2. And then I'll follow this exact same thing in reverse to get as many points listed on here so I can find the solution way easier when I make my line. So here we go again with this line making process on the screen. Okay, 1, 2, 3. That did not come out as good as I thought, but whatever. Now let's go ahead and graph our first equation. I'll change its color. And we have it in standard form, where 3 is our A value, positive 6 is our B value, and negative 12 is our C value. So once again, to get our y-intercept, we just go ahead and take our C value divided by our B value, which is negative 12 over positive 6, and that gives me a answer of negative 2. So negative 2, which is already pretty close, is down here. Now let's go ahead and go to our slope, and our slope is the opposite of whatever A is divided by B. Well, our A value is a positive 3, so the opposite of that is negative 3. Divided by B is a positive 6. Negative 3 over positive 6 simplifies to negative 1 over 2. That looks awfully familiar, like the same slope I had right there. So I'm following the same exact pattern. Well, in this case, if I have two lines that are following the same exact slope, then there is no intersection. And if there is no intersection, then there is no solution. So let's go ahead and graph this line, which didn't come out. Let's try this again really fast. That was really bad. Don't hate me, guys. But you get the big idea. So we have no solution because these lines are parallel. The giveaway in the future, if you ever notice, is when you have the same exact slope, negative 1/2, negative 1/2, your lines will never intersect. That's a quick way of identifying it. And let's go on to our next two examples now. Numbers 5 and 6. So for number 5, we have 2y equals 8x plus 18, and then 24 plus 4y equals x. Neither of these two are in standard form or in slope-intercept form. So it's up to me to pick one of those forms and get it into. If possible, simplify these things. Like for the example, in the first equation, 2, 8, and 18 can all be divided by a similar number, in this case, 2. You can only do this method if everything is divisible. If only the 2 and the 8 were divisible, but I had, like, let's say a 19 at the end, then I couldn't do this trick. So remember that. That's a very crucial rule. So I'm going to take the 2y equals 8x plus 18 and divide everything by 2, which is the biggest number that goes into everything here. I get y equals 4x plus 9, which gives me an equation in standard form that I can graph fairly easy. Positive 9 is my y-intercept, and my slope is 4, or 4 over 1, up 4 over 1. Well, I can't go up 4 over 1 until we run out of space, so I'll use the slope in reverse, which is back 1, down 4. Back 1, 1, 2, 3, 4. Back 1, down 4. Back 1, down 4. Back 1, down 4. I hope I get this right. And with my straight edge, I'll go ahead and try to make a decent line. Being left-handed, these positive lines seem to be a little easier for me to make. But the negative lines seem to be a little more difficult on the screen. Now my second equation, 24 and 4 could both be divided by 4, but that single x cannot. So in this case, I cannot use the process of dividing everything to try to get a single variable. What I'm going to have to do is move stuff around. I think the easiest method would be to get the x and the y on the same side. So I'm going to go ahead and take the 24 plus 4y equals x, and I'll go ahead and just subtract 4y from both sides. Doing that gives me a positive 24 equals x minus 4y. I can handle this because this is standard form, and I did this in the last two problems. I can get my y-intercept simply by taking the c value, dividing it by the b value. In this case, my a value is right here, my b value is right here, and my c is over here at the end, but it'll still work. So my c value is 24, and my b value is a negative 4. 24 divided by negative 4 is a negative 6. So here's my y-intercept right here of my second line. Now to get the slope. The slope is going to be the opposite of a over b. Sorry, I'm running out of space. So the opposite of a is a positive 1, so I'll have a negative 1, in this case the opposite, divided by b, which is negative 4. Remember, a negative divided by a negative is a positive, so 1/4 is my slope. Up 1 over 4. So up 1, 1, 2, 3, 4. Up 1, 1, 2, 3, 4. And I can follow it in reverse. Back 4, 1, 2, 3, 4, down 1. Look, I have an intersection right there, 2, 3, 4, that I can hit, and there is my solution. So remember to always graph as many points as you can on these grids. And look at that line, that's way better than the other ones I did. Kudos to me. And finally, let's go ahead and do our last example, which is number 6. Number 6. My first equation looks like slope-intercept form, except we have that negative y. So we can use some basic math logic. I can multiply everything by negative 1 and make everything the opposite, which then gives me positive y equals positive x plus 6. Because that's what multiplying by negative 1 does, it just changes the sign of everything. I can graph this very easily. Here's my y-intercept at positive 6, and my slope is this invisible 1 over 1. So let's get all these points that I can on here. I'm not sure how many I'm going to need, but I'll try to get them as best as I can lined up. And let's graph this. That was horrible. But yours will look a lot better because you're using your IDs or a ruler. And our second equation, 3x plus 18 equals 3y. All three terms can be divided by 3. This 3, this 18, and this 3 can all be divided by 3. So I'll go ahead and divide each one by 3 to make it easier. And I get a single x plus 6 equals y. And this again is basically slope-intercept form. So when I graph this, I have a y-intercept of positive 6, just like the first line, and the same slope of 1 over 1. So what I have is the same exact line on top of it. And where do these two lines make contact? That would be everywhere. So this would be an example of infinite solutions. All right, I'll follow up this video with a substitution video. So best of luck, guys, and I hope this helps.